Hello dear students, welcome to chemistry class. In this class we are discussing about the acidic character of phenol compared to alcohol and cyclohexanol. Acidic character of phenol compared to alcohol and cyclohexanol. And first of all, we know that acid is nothing but a proton donor, that is H plus donor, and the strength of this acid completely depends on the ease of donation of the proton. Strong acid means which is easily donating a proton, weak acid means which is slowly donating a proton. And first I am comparing the acidic character of phenol with the alcohol, and here I am writing the structural formula for phenol and alcohol. This is phenol, and here I am writing the structural formula for the general alcohol, that is ROH. This one is alcohol, and no doubt here both these molecules are having hydrogens, and these two can act as a acid by donating proton, but phenol is more acidic as compared to the alcohol. Phenol is more acidic as compared to the alcohols, and the pKa value for phenol is about 10, and for that of alcohols pKa value is in between 16 to 17, and we know that lower the pKa value, higher is acid strength. If the pKa value is low, then it is strong acid, and if the pKa value is high, then it is a weak acid. Why? Because pKa can be calculated by using the formula negative to the log Ka. Okay? Therefore, this phenol which is having the pK value of 10 is strong acid as compared to the alcohol. Why? Okay. Let me explain this concept, and here I am taking phenol, and after the loss of proton, this phenol is converting into its conjugate base. Its conjugate base, that is a phenoxide ion. This one is a conjugate base of this acid. Phenol, after the loss of proton, it is forming an phenoxide ion, and this one is a conjugate base of this phenol or an acid. And alcohol, after the loss of proton, forming an alkoxide ion, and this one is a conjugate base of this acid, that is alcohol. And now, no doubt both are the acids, but here I am telling phenol is more acidic as compared to the alcohol, and the acid strength or the acidity of the molecule is directly proportional to the stability of formed conjugate base. The acidity or the strength of an acid completely depends on the stability of the formed conjugate base, and here these two are the formed conjugate base, and in these two which one is more stable, that one is giving a high strength of an acid. And here this phenoxide ion is more stable as compared to this alkoxide ion. Why? Because see here, the stability of this phenoxide ion can be explained by drawing the resonance structures for the phenoxide ion. This phenoxide ion will stabilize the negative charge on the oxygen by delocalizing this extra pair of an electron. I am writing the resonance structures for this phenoxide ion. I think you all are familiar with the resonance structure. Okay, finally we will get this one. Once again phenoxide ion, but the only difference is there in the position of this is also phenoxide ion, this is also phenoxide ion, but the only difference is there in the position of an pi bonds. Okay, and this is the resonance, and we know that resonance will stabilize the ion. More the number of resonances, more resonance structures, higher will be the stability. Correct? More the resonance structures, higher will be the stability. And here this benzene ring will stabilize this formed phenoxide ion by resonance, by the delocalization of this negative charge on the oxygen throughout the benzene ring. This phenoxide ion can be stabilized. Therefore, phenol always wants to be there in its stable form, that is a phenoxide ion form, by losing proton. But coming to this alcohol, that is alkoxide ion, here we can take R as any alkyl group like methyl group or ethyl group or propyl group, like etc. But we know that these all alkyl groups are electron donating, which are imparting plus I effect on this negatively charged oxygen. These R groups will donate electrons towards the negatively charged oxygen instead of stabilizing this one. Therefore, because of this reason, the phenol is more acidic as compared to the alcohols, only because of presence of stabilizing factor. Here the resonance effect is governing the stabilization of the phenoxide ion. Here inductive effect is destabilizing the formed negative charge on the oxygen of an alkoxide ion. And coming to the comparison of phenol with cyclohexanol. Phenol with cyclohexanol. This is a phenol and this one is a cyclohexanol. And here also after the loss of proton, this phenol will form phenoxide ion, and here this cyclohexanol after the loss of proton will form an alkoxide ion. Okay. Then here this benzene ring will stabilize the formed negative charge on the oxygen, but here no stabilizing groups are there to stabilize this negative charge present on the oxygen. Here resonance is there, here resonance is not there. Therefore, the phenols are more acidic as compared to the cyclohexanol also. Then we can say phenol is more acidic than alcohol, which is more acidic than cyclohexanol. We can write the pK values. In bracket I am writing the pK value. For phenol it is 10, for alcohols it is between 16 to 17, for cyclohexanol it is at 18. And if any electron withdrawing groups are there, like nitro groups on the benzene ring of phenol, this is a phenol, if any electron withdrawing groups are there like nitro group on benzene ring of the phenol, these will increase the acidic nature of the phenol as compared to the just phenol. We can write this one. Para-nitrophenol is more acidic as compared to the phenol, and if electron donating groups are there, if electron donating groups are there like methyl on the benzene ring of phenol, these will decrease the acidic nature of phenol as compared to the just phenol. Okay. If electron withdrawing groups are there, then these will increase the acidic nature of phenol, and if electron donating groups are there, and these will decrease the acidic nature of phenol. And if we have nitrophenol, phenol and cresol, we can write like this: nitrophenol is more acidic as compared to the phenol, and phenol is more acidic as compared to the cresol. And here we can also write the pKa values for these. This nitrophenol, that is a para-nitrophenol, is having a pKa value of 7.15, and for that phenol the pKa value is about 10. Then for ferrocresol, the pKa value is about 10.19. Then we know that lower the pKa value, higher is its acidic nature. Okay. Then why these electron withdrawing groups are increasing the acidic nature of the phenol? Because here this electron withdrawing group will further stabilize or further delocalize the formed negative charge on the oxygen of this phenoxide ion, whereas the electron donating groups will further destabilize the formed negative charge on the oxygen of the formed phenoxide ion, that is the formed conjugate base. Then we can write one conclusion that phenol is more acidic than the alcohol, because here it is having a stabilizing group, that is a minus R, that is a resonance group is there, but here in alcohol plus inductive effect is there. Whereas we can write phenol is more acidic than cyclohexanol, here minus R effect is there, that is a resonance effect is there, and here no stabilizing effects are there. Here no stabilizing effects are there. Okay. Thank you.